Hi, this is N2QOJ. The presentation I prepared discusses cellular phone systems. There's a common misconception that cell phone systems fail during times of emergencies and other high usage unplanned events. In actuality, the cell phone system does not fail. It's you, the average person's ability to make successful cellular calls. That probability is extremely low. In this presentation, you'll find out why that is. Any feedback is always appreciated. My contact information is in the presentation. Thank you very much and enjoy it.
Hi, this is Joe, N2QOJ. I've prepared this presentation for all of you, and I hope you enjoy it. As hams, quite a few of us have heard this line: "When cell phones don't work, ham radio does," or more commonly, "When all else fails, ham radio gets through." And that, by and large, is a true, correct statement. However, why do cellular communication systems fail? I think that's an important question. I think the answer is important. I think it's important for us to know and be able to articulate that to common folks out there who are not radio savvy. And it helps us in our goals and objectives. And I think you'll feel enlightened and learn a few things here. So let's proceed. Let's get to some basics. I think we all can relate that when we're having radio communication between a couple of vehicles, a base and a mobile, whatever, we are basically communicating in what's commonly known as half duplex, or one person's talking, press to talk, release to transmit. Release to listen, and another person is listening. We're using one frequency, one party can talk at a time while the other is listening. That's simple radio. When we get into a radio system that allows us to speak and listen at the exact same time, that should bring to mind a standard telephone. That's how we use a standard landline wire telephone. It's how we use a cellular phone, right? You can speak, you're not limited, you can actually be hearing what's going on as well at the same time. And we all know that a handheld cell phone is a radio system. Actually, it's multiple radios, right? Quite a few different radios for the multiple bands of the cellular bands. It may have Bluetooth radio in it. Certainly, most smartphones have Wi-Fi radios in there. Near field communication radios. So that little handheld device has got many different radio systems and lots of capabilities. But remember, full duplex. A cellular phone is operating in full duplex when one party can hear the other and talk at the same time. That requires two frequencies. Remember that. Important for more information coming up. Let's look at a basic cellular system layout. Why do we call it cells? Well, the way cellular phone systems are designed for an area or a region, they're laid out in cells. These hexagonal cells accurately represent the electrical characteristics and RF characteristics once laid out. Now, these cells could be all same size cells. They could be varying in metro dense located areas. They could be only a mile or 2 mile wide. In other areas, they could be 5, 6, 7 miles wide. Okay. The important thing to know that every cell has a cell station, a tower, and a base station, and that's for proper transmit, receive, and control, and so forth. This graphic really demonstrates that when you have cells in an area, and if there's two people communicating and they're not in adjacent cells, frequencies or frequency pairs can be reused. Very low power is required to contact and maintain communication with a cell tower. Matter of fact, a cell tower actually understands how much power is necessary based on your signal. It understands that, and it can actually send a signal to your phone varying its power. That way, power levels are maintained such that there's no interference in adjacent cells, and frequencies can be reused. Now, cell sites are fixed, but we are not. We can be mobile. All right, we could be moving around within a cell, cell to cell, and this graphic is an indication of how, a vehicle moving along a major roadway, and most major roadways in the United States have cellular systems along that path, even if there's not much around. Usually most interstates will have phone systems throughout, or cell systems, I should say, cells along that path. The reason for that? People need to make calls. They need to be in contact with family and friends and business. And the carriers, cellular carriers, are not going to miss the opportunity to generate revenue from that. And you'll see here, generating revenue is an important driver to what most any cell carrier does in terms of laying out their cell system, expanding them, and so forth. But as you travel, your signal during your conversation is passed from one cell to another, and that doesn't always have to be the same cellular carrier. You could be venturing into a boundary of their coverage into another. So you've heard the term roaming. It can be handed off. These cellular companies have agreements in place, technical and financial agreements in place, so there is no drop. Your phone call can continue, and all parties are billed, and all parties are collecting revenue as necessary. Let's look a little bit at the history of some of the cell carriers and systems. There's 3 or 4 main systems of how cellular systems can actually work technically. You may think that there's only one, but in reality there's multiple. The GSM system, the Global System for Mobile Communications, which actually began in Europe, is what is used quite often here. And AT&T and T-Mobile are GSM systems. They have SIM cards. That's a feature of GSM. And they're a combination of frequency and time domain multiplexing. We'll talk a little bit about that. But basically, remember this. Anytime you hear the word multiplexing, you are trying to get more out of something that's not designed to do that. People multiplex electrical lines, fiber optic lines, and the reason they're doing multiplexing is so they can actually get more usage out of an area that wasn't maybe originally designed for the bandwidth or load that you're trying to put on there. So remember multiplexing. GSM typically has forward links and reverse links, each spaced about 25 megahertz apart. In practice, that could be as much as 45 megahertz. In other words, 2 channels are required for a conversation. They'll probably be spread 25 to 45 megahertz apart. Okay, very similar to ham radio with repeaters and duplexers and so forth, when we have 5 megahertz shift in 440 band and so forth. The system is broken up to multiple channels. They're allocated a spectrum by the FCC, a certain spectrum of frequency usage. They divide that up into what their system is designed to handle. And there's multiple channels of 200 kilohertz each. That represents in the spectrum for AT&T and T-Mobile about 125 channels total. Okay, starting to get the picture. 125 channels total. You need 2 channels for a cellular conversation. They can be reused in cells, but you're starting to see these are not big numbers. Now, for multiplexing, each of those channels are broken into time slots. A little bit more about that later. The time slots, remember, this is digital transmission, so we are encoding this analog. The telephone, the cellular phone, is taking this analog voice of yours and basically turning it into digital information. Okay, you need a certain amount of bandwidth for that, and notwithstanding all this math here, basically the time slots by the time you're done are only a little bit more than half a second long. Okay, what that means is if you have 125 channels you start with and 8 slots per channel, you can actually get about 1,000 users on those 125 channels. Okay, again, that's 1,000 users. That's not 1,000 conversations. It's more like 500, right? With 2 on each end, 1 on each end. However, the 1,000 channels is not all voice channels. There's control channels, there's logical channels, and these things transmit control, signaling information, data in various different modes, general packet, radio system, voice data, and so forth. So not all those channels are dedicated to voice conversations. Look at it from a different way here. Here's a simple frequency division multiplex system. Let's call this GSM just for basics. Okay, there is a spectrum 824.04 to 893.7 megahertz that's been allotted for it, right? And this is frequency division multiplex, and that's a 45 megahertz region or spectrum band. Okay, that's finite. Okay, so there's basically 125 channels, 8 slots, potentially 1,000 channels in there. Now, here is this is time division multiplexing. There's the same frequency spectrum that the FCC has allocated. However, this service, time division multiplexing, which is what Verizon uses, what they do is something interesting. They'll take that same spectrum, but they'll break it up into time slots. When you take that same spectrum, if you look across here, 1, 2, you have 3 basic time slots for the same frequency. That means I can now fit 3 times more information, voice data, and so forth in that same slice of bandwidth. Okay, hence I'm getting more capacity. Right? Capacity is a big word here that we use in cellular systems. So, through some encoding, what this means is that when you create these time slots, you have to create frames. And frames is just a nice word that indicates that frames have to be identified specifically for each of the conversations in order for the controlling electronics to understand how to piece them all together, keep them separate, tie them to conversations, and so forth. Let's look a little bit at carrier division multiplexing. And I'm sorry, this is actually Verizon. This is what we're doing here is you notice the frequency spectrum here of 1850 megahertz and 1990, a little bit higher spectrum, right? There's additional coding that's going on. Now remember, the first examples are frequency. We're taking frequency, dividing up those channels into conversations and control. The second one was time. We're introducing frames. We can put more conversations in each of those frequency slots by breaking up the time, because electronics can actually work much faster than digitized conversations. So that's good. Here, this is completely different. We are taking conversations and we are encoding in the beginning and in the end of these bits and pieces of digital conversations identifiers. Digital identifiers. Imagine every transmission you make has an identifier. Well, the way this system works is that it can take these identified pieces of conversation and it knows which goes with which. So conversation A, the 2 parties involved there, each have the same encoding in their conversation. What this allows is now you don't have to have a finite system. You can have many more conversations here, because the controlling electronics at the cellular stations are picking up these things and piecing them together. So as much as you can feed in, it can take and put together. In reality, is that really what's going on? It is, but is it finite? It is finite. Why? Because eventually noise figures and congestion and so forth will actually limit what you're able to do here. Alrighty, moving on. Let's wrap this up somewhat here into a summary. As you've seen from the AT&T and T-Mobile example with frequency division multiplexing, time division multiplexing, by design, those systems are finite, right? The 125 divided by 8 slots, 1,000 channels. CDMA, the last one we saw, doesn't have that limitation. As much as you can pump in, it'll try to put those conversations together. However, the physical limitation that comes in is basically noise. As more and more conversations are introduced into the system, and the electronics have to figure out and keep and filter away the non-identified parts of that conversation, it really gets to be a situation where it's noise. Everything but the conversation you're interested in picking out becomes noise relative to each other. And the more and more you do that, the noise floor continues to rise, and then weaker signals of conversations don't make it through either. So it does become finite. All of these systems become finite, either through initial design or by the actual physics and electronics in use. So that is called degradation in the CDMA world. Conversations, noise floors, and so forth will degrade and limit you. There's an excellent article that you can reference on how phone networks could potentially, or will they potentially, be fixed in terms of these overload situations. And I think you'll find interesting reading. Not giving away much, but remember, companies are out to make money, generate revenue. They are not going to design systems for capacities in an emergency that they'll hardly ever use. So it would be billions of dollars, and that's not going to happen. So, if cellular systems are finite, and we know that in times of emergency, now you understand why. If you look at a situation with a stadium with 50,000 people, or a state fair, 15,000 people, and there's an event or something that goes wrong, or even something, somebody wins the Super Bowl and everybody's calling home. Now you can understand why the systems reach capacity. The systems reach capacity. Remember that. They reach, in an unplanned event or an emergency, they reach capacity extremely quickly, and users experience failure in being able to connect their calls. That's what is going on. They don't fail, they're reaching capacity, and it's a capacity that's not going to improve based on the economics involved. However, is there a way to prioritize cellular phone systems or telecommunications in general? And you know what? There is. It's been going on for some time. The Department of Homeland Security has an Office of Emergency Communications. This Office of Emergency Communications has defined several programs for law enforcement, national security, agencies and businesses that are vital to the operation of a country in times of this, and these programs allow them to enroll and receive priority in these types of situations. Priority in actually making real-time calls, priority in getting their infrastructure back up and running and serviced. Give you a little bit of perspective here on the Priority Telecommunication Services brochure that the Office of Emergency Communication here puts out. and it's by the Homeland Security, Department of Homeland Security. Briefly, what it basically, its intent is to offer training, coordination, tools, and guidance. The OEC coordinates federal, state, local, tribal, and territorial governments and industry partners to ensure that communications are available at all time. That's a mouthful. What it really talks to is the government, through government sponsorship. These programs have been put in place with cell carriers and wireline services, and it's not free. There is a cost associated with every one of these. So all of the cellular carriers and telephone companies have jumped on board without any problem to this. What does it mean? It means that there is, in the situation, here, for every situation, if you look at the OEC, the three main programs that have been designed, it's the GETS program, Government Emergency Telecommunications Service, WPS, Wireless Priority Service, and TSP, Telecommunications Service Priority. The GETS system, Government Emergency Telecommunications Service, is basically the program that agencies and organizations can enroll in for their wireline services, telephone calls, landlines. They can get priority. They're issued calling cards, if you will. That's basically the way it's done. There are charges to these calls, but there is priority, okay, given to these landline services for these companies and organizations that can qualify. Complementary to that, the WPS, the Wireless Priority Service, exists for wireless carriers and customers. And basically, same thing. You sign up if you have a law enforcement or other public safety agency that qualifies. And in times of events like this, you will have priority. Here's an example. Here's a very interesting statement. For example, up to 95% of WPS calls were successfully completed during the 2013 presidential inauguration. After the Boston bombing, up to 93% of all calls placed through WPS were successfully completed, allowing critical personnel to carry out their missions. Okay? Keep in mind, these things have been in place a very long time, and they do work. Okay? Again, you subscribe to it, and there's a charge for that. The telecommunications service priority is for those agencies and organizations that have had their services disrupted, damaged, either by natural disaster or a terrorist attack. These organizations that qualify for this program will get their systems repaired and online before others. They've thought of everything, for the actual phone calls and process and the infrastructure itself. So these three systems do exist. Okay? And this is why priority can be had. Now, here's an interesting thing. As you get into discussions about these kinds of things, you'll start seeing interesting articles. Now, all I did was basically Google, cellular systems, priority, usage. This interesting thing came up. Why cops don't just use cell phones? Well, this gentleman indicates that cops who are carrying very expensive radios don't use them because if they were to use cellular phones, there's no priority. Cellular networks don't prioritize their users or traffic. A teenager's cell phone has the same priority as a cell phone used by a police officer, or for that matter, the BlackBerry used by President Barack Obama. We've all experienced no circuits available or network busy when using a cell phone. Well, hold on now. How could that be? We just saw that the government has in place several programs for not only cellular but wires, landline services that do prioritize. Who is this guy, and why is he putting out this kind of information in a magazine called Government Technology? Well, let's check on him a little bit. He's probably nobody of any importance. Well, isn't it interesting? This guy was a senior policy advisor in the Office of Chief Information Officer at the state of Washington. Well, that's pretty good credentials. In that capacity, he chairs the State Interoperability Executive Committee, serves as the primary point of contact for the FirstNet effort in the state, and advises the CIO on other matters. In the past, he served as Deputy Director of the Center for Digital Government. He also retired in May after serving over 8 years as Chief Technology Officer for the City of Seattle and Director of the city's Department of Information Technology. This guy is all about information, so why is he so uninformed? Well, let's see. He's also was named one of Government Technology's 25 doers, dreamers, and drivers in 2008 and a premier 100 leader of 2010. That's quite interesting. And here's his contact information. Well, I'd like to send him a message. Now, why would someone with those kind of credentials put out such a comment like this, that cellular networks don't prioritize their traffics or users? Well, you know what? Maybe this was written well before those 3 programs came in place. This is written in 2010. After all, it is 2014. Well, you know what? That's not the case. With a little bit looking, look at this. Police Chief Magazine in 2006 reminds police chiefs throughout the country, or whoever's, got a subscription to them, that communications, when all wired and wireless telephone circuits are busy, priority telecommunication service for first responders. Make use of the programs available by the government. Look at this. Wireless priority service, GETS, telecommunications. In 2006, professional law enforcement officials were being reminded, make use of these services for your first responders. Well, that's in 2006. That's a full 4 years before this guy. I guess he never got to read some of that. How far back does it go? 2003. Cellular priority system begins operation. Mobile calling for emergency response is up and running. 2003. So this has been in development for quite a long period of time. So be aware. The takeaway from this is be careful of what you read in the press about these kinds of issues with emergency communications. Obviously, if you continue reading this person here who's been retired for 8 years as of 2010, he has another agenda. And absolutely, as you follow this article, the agenda is quite simple. He is lobbying for telecommunications companies, for the public safety first responders corps, to get its own LTE cellular systems dedicated just for them. Well, that must mean billions of dollars for infrastructure. So that gentleman has an agenda. So getting back to our presentation here. Can you hear me now? No. What'd you say? Ham radio? Can you hear me now? Well, you bet your butt I can hear you. Absolutely. And I know where you are. And I know what kind of assets you got there, both human and hard. And I probably know a lot more about you too. Ham radio makes sense. So until something better comes along, make sure you're aware of it. What can you do? Learn about texting. One aspect of cellular phone systems is texting. SMS texting, short message system texting, is a wonderful tool, and it succeeds where voice communication does not in emergencies. The reason for that is voice communications are two parties. A call has to be connected and established, and billing starts. Well, in a situation where capacity is maxed out, that never happens. No billing can happen, so you're locked out. Texting is different. Texting does not require a call connection. you text, it goes out there, it will find its delivery point eventually. The systems store and forward that information. Texting is a very reliable communications alternative. What you need to do, though, is not wait until it hits the fan to go texting and learning how to text very well. Plan on how you will text to friends and family. Stick to what, where, and who. Keep them short. Understand who you're going to text and why. When it comes to radio, plan on what frequencies you're going to use for your both local and regional, for your own interfamily communications, but also communications with your community and other hams and support groups. Drill with cellular texting and radio with your family and friends on a regular basis, once a month, couple times a month. The point is, do not wait for an unplanned event. That's the worst time to do it. Basic texting, by the way, you know, if you don't have your phone available and you need to send out some emergency texting, and you're at a computer or a laptop or whatever the case may be, a smart mobile device, you can actually email to people in the field, phones, friends and family and others who are actually roaming around, running around with phones. All you need to do is have their 10-digit phone number and know their carrier service. If you don't know their carrier service, send it to all of them. Okay? These are just some examples of 4 different carriers: T-Mobile, AT&T, Verizon, and Sprint. And this is how you would send a message, text, by email directly to their phone, and they can respond. It'll come directly to your email. It's a great way of utilizing texting if you just don't have a phone to access. You could do your own demonstration on this. So, links to review some of the things I've showed you here, the links are provided here. Okay, go and read for yourself. Read these brochures. There's a brochure and takeaway type of item for every one of those public or those public safety and first responder programs that the government has set up. So thank you very much for viewing this presentation. As always, if you have any questions or comments, please contact me through jsammartino@gmail.com or queencreekarc.org, the website of the Queen Creek Amateur Radio Club. Full contact information is there too. 73